Good morning, students. Our new topic in the topic of acid, basis, and salt in the subject of chemistry O levels is the preparation of salts. So, this is very important topic. So, concentrate yourself. A salt is an ionic compound formed when the hydrogen atom in an acid is replaced by a metal ion or an ammonium ion. So, very important, when hydrogen from acid is replaced by metal ion or ammonium ion, salt is formed. So look now, here is a cartoon that is actually representing the process. So here is ACl. So this H is going to be replaced. This is a metal ion which is telling him that I'll take that Cl. So this H is fighting with it, but in the end this Na will win and this will take Cl with him. So H is repelled. So a salt is formed. Salts of hydrochloric acid are called chlorides. So this is very important points now. Salts of hydrochloric acid are called chlorides. Salts of sulfuric acid are called sulfates. Salts of nitric acid are called nitrates. Salts of sulfurous acid are called sulfides. Salts of carbonic acid are called carbonates. And here are the examples of sulfurous acid, that is H2O plus SO2, and salts of the carbonic acid, that is H2CO3, are called carbonates. And here are some more examples. Hydrochloric acid salts are called chlorides, and here are some examples: NaCl, ZnCl2, FeCl2, and NH4Cl. The salts of the sulfuric acid are called sulfates, and there are some examples: sodium sulfate, magnesium sulfate, iron sulfate. And the salts of the nitric acid are called nitrates. So here are some examples: sodium nitrate and zinc nitrate. Solubilities of salt in water. All nitrate salts are soluble. So you have to remember all these points. I have precise the topic, very precise notes are these are. So remember each and every point. So there is nothing useless. So concentrate yourself. Solubilities of salt in water. All nitrate salts are soluble. All group 1 metals, for example sodium and potassium salts, are soluble. All ammonium salts are soluble. All adonate salts are soluble. All chloride salts are soluble except silver chloride and lead chloride. All sulfate salts are soluble except calcium sulfate, lead sulfate, and barium sulfate. All carbonate salts are insoluble except sodium carbonate and potassium carbonate and ammonium carbonate. These 3 salts are soluble. Other than all carbonate salts are insoluble. All lead salts are insoluble except lead nitrate and lead ethanoate. Here are some key terms. If we heat the salt solution, water evaporates off. Small crystals of salt start to form. This is called the point of crystallization. When colorless crystals of sodium carbonate dehydrate, example is here. So when this is allowed to dehydrate, washing soda are left out in the air. They become coated with a white powder. It is found that this white powder is the monohydrate formed by the process. So look now, this carbonate, sodium carbonate dehydrate, it is allowed to dehydrate. So it is left with it and 9 molecules of the water will be hydrated. When a hydrate loses its water of the crystallization in this manner, It is said to be efflorescence, and the process is called efflorescence. With some substances, not necessarily salt hydrate, the reverse of this process occurs. For example, if sodium hydroxide solid is left in the air, it absorbs water vapors and eventually form a very concentrated solution of the sodium hydroxide. So this is the reverse process of the previous one. So when some substances are left into the environment, they absorb water from the environment. And this process is called deliquescence. They are said to be deliquesce. Water content of the crystals give crystals their shape and their color. It is called water of the crystallization. So this is very important term. The content of the water content of the crystals gives crystal their shape and color, and this is called water of the crystallization. Some substances, if left out in the air, absorb water vapors but do not form solutions or change their state. For example, concentrated sulfuric acid absorbs moisture from the atmosphere and becomes diluted while still remaining a liquid. Substances which do this are said to be hygroscopic. So very important term. They do not change their shape but absorb water from the atmosphere and become dilute. They are called hygroscopic. If no more salt can dissolve in the solution, this is called saturated solution. If more salt can dissolve in the solution, this is called unsaturated solution. And if no more salt can dissolve in the solution even after heating, this is called supersaturated solution. Salts can be obtained from seawater in hot countries like this. They bring water out of the sea and throw it on the shore. Water evaporates and left salt. The next thing that we are going to read is the preparation of the soluble sodium, potassium, and ammonium salt. Soluble. Okay, concentrate now. These salts are prepared by the titration method. The preparation are based on the neutralization reaction, and this is the neutralization reaction. Acid plus alkali forms salt plus water. And the explanation is here. 25 centimeter cube of 1 molarity ACl into a conical flask and add 2 to 3 drops of phenolphthalein. Slowly add hydroxide from the burette into the conical flask while shaking the flask until the indicator changes color, that is first appearance of pink. Note the volume of the alkali needed to neutralize the acid from the burette. So burette will have marking. So note the amount of the alkali that is required for changing the color. Note the volume of the alkali needed to neutralize the acid. Repeat the titration by adding this volume of the alkali into 25 centimeter cube of 1 molarity ACl without using the indicator. Allow the neutralized solution to evaporate until it is saturated. This saturated solution is allowed to cool so that crystallization can take place. So now the solution will allow to cool and crystallization will be made. Filter out the crystals and dry them between the two pieces of the filter papers. Okay, the next topic which we are going to read is the preparation of the soluble salts other than sodium, potassium, and ammonium salts. So concentrate yourself. These salts are prepared by the reaction of the acids with metals, insoluble bases, and insoluble carbonates. So here are the reactions when acid and metal react, when acid and base react, and when acid and carbonate react. Soluble salts other than sodium, potassium, and ammonium are made. Example is here. preparation of the copper sulfate. So the reaction will take place. CuO plus H2SO4 will form CuSO4 plus H2O. And the method will be this one. Making a salt from an acid and base. Put 25 centimeter cube of sulfuric acid in a small beaker like this. Okay, sulfuric acid is here. Add black copper oxide and stir with a glass. So copper oxide is going to be put into the sulfuric acid and stir. Keep adding the copper oxide until no more will dissolve. How do you know when all the acid has reacted? Okay, filter the mixture in your beaker. So now you are filtering the mixture into your beaker. Copper sulfate solution is here now. You should get a clean blue solution. So solution will be blue color. Pour your solution into an evaporating disk. Then heat it on a water bath as shown. So this will be the process. This solution will be put into the dish and will heat it on the water bath. Stop heating as soon as you see some crystals around the edge of the solution. Leave the solution for a few days to crystallize slowly. So this will be the process of making a salt from an acid and a base. Okay, here is another example, that is hydrochloric acid is neutralized by copper carbonate. The reaction will be 2HCl plus CaCO3 forms CaCl2 plus H2O plus CO2. And the method will be preparing a salt from an acid and a carbonate. 25 centimeter cube of hydrochloric acid in a small beaker. So here is beaker and 25 centimeter of hydrochloric acid will be put into it. Add a spatula of copper carbonate. So here is copper carbonate is going to be put into the hydrochloric acid. Add more copper carbonate until it stops fizzing. Filter to remove the unreacted copper carbonate. So it will be filtered now. Repeat step 3 from the end of the experiment 12.3. Okay, to get some crystals of the salt. So the previous steps will be followed and it will be put into a dish and will be heated on a water bath, and then crystals will be started to form around the edge of the dish. Then you will allow this dish to cool and then crystals will be formed. The next thing that we are going to read in the lecture is preparation of the insoluble salts. These salts are prepared by precipitation via a double decomposition reaction. So double decomposition reaction will be occurred to form insoluble salts. The solid obtained through this reaction is called precipitate. Look at the cartoon below. It explains what happens in a precipitation reaction. So first AB was combined and CD were combined, and after that A and D will be combined and B and C will be combined. So this is called double decomposition reaction. Example is preparation of the lead iodide. So reaction is PbNO3 twice plus NaI forms PbI2 plus NaNO3. And here are the steps making an insoluble salt by precipitation. Take 5 centimeter cube of lead nitrate solution in a test tube. So here is a lead nitrate solution. Add 10 centimeter cube of sodium iodide solution. So sodium iodide solution is also added. Lead nitrate is 5 centimeter cube and sodium iodide is 10 centimeter cube. Filter your mixture. The solid lead iodide is left on the filter paper and Okay, lead iodide will be left on the filter paper. Rinse it with distilled water. Okay, scrape the salt made on the some fresh filter paper. So this will be the thing, lead iodide, which will be left on the filter paper. Scrape the salt made onto some fresh filter paper. Leave it to dry. So this will be the method to make this kind of the salt. The next topic which we are going to read is the centrifuge. The solids in precipitation reactions are formed as very small grains. The mixture is called a suspension. A centrifuge is a machine which spins test tubes around at high speed. So this is centrifuge machine. What do you think happens to the tiny particles of the precipitate? Think about what happens to you on a ride that spins around quickly at a fairground. So you will, everything will be like you will feel round. Okay, after centrifuge, the solid is packed at the bottom. The solution above can be poured off, decanted. The precipitate is then washed and dried. So this will be the thing that will happen after spinning the tubes in the centrifuge at a high speed. So the solid is packed at the bottom. The solution above can be poured off. The precipitate is then washed and dried. Okay, testing salts is the new topic. We can use precipitation reaction to test for some negative ions. We can see if a salt is a chloride, bromide, iodide, or sulfate by the test below. Look at the table below. You dissolve the salt in dilute nitric acid, then do the test below. So first the salt will be dissolved in nitric acid, and then the next test will be silver nitrate solution. A white precipitate of the silver chloride, if formed, that will be called chloride. Okay, if first the salt is dissolved in nitric acid and silver nitrate solution test is done, if a cream precipitate of the silver bromide is formed, so cream precipitate is formed, then the salt will be bromide. If a salt is dissolved in dilute nitric acid, then silver nitrate solution test is done. If a pale yellow precipitate is formed, then the salt will be iodide. If the salt is dissolved first in the dilute nitric acid and then barium chloride solution test is done, if white precipitate is formed, then the salt will be sulfate. The next thing that we are going to read in the lecture is metals in salts. Salts also contain a metal. The metal part of the salt is always a positive ion. The colors in these fireworks are made by the metal ions. So this is the function of some metal ions, metals in the salts. We can also identify some metals using a flame test. So here are a test that is called flame test for identifying the metals. So flame test for metals. You can test the unknown salts from experiment. Take the color out of the Bunsen flame by opening the air holes slightly. Heat a piece of the nichrome wire in the flame to clean it. So first clean the flame. Then put the loop at the end of the wire into some water. So some loop, first loop will be put into the water. Then dip it into one of the unknown salts. So unknown salt is there now. Hold the wire in the edge of the flame like this. Record the color. Clean the wire again and test the other salts. So, if the color is scarlet red, it will be lithium. If the color is bright yellow, it will be sodium. If the color is potassium lilac, it will be potassium. If the color is brick red, it will be calcium. If the color is green blue, the salt will be copper. And if the color is apple green, the salt will be barium. So this is called flame test. Okay, next we are going to read the uses of the salts. Uses of some salts are given below. This is very important. This question frequently come in the paper. Give some uses of the salts, and the numbers are 2 to 3 or 3 to 4 marks. Question is this normally come in the paper. So the first salt is silver bromide, and its use is in the photography. Next salt is calcium carbonate. It is used in the extraction of the iron, making cement and glass making. Next salt is sodium carbonate. It is used in glass making, softening water, making modern washing powders. Next is ammonium chloride. It is used in torch batteries. Next is calcium chloride. It is used in the extraction of the sodium, dyeing agent and hydrous. Next is sodium chloride. It is used in making hydrochloric acid for food flavoring, hospital saline, in solvage process for the manufacture of the sodium carbonate. Next is tin fluoride. It is used as an additive to toothpaste. Next is potassium nitrate. It is used in fertilizer and gunpowder manufacture. Next is sodium stearate. It is used in soap manufacture. Next is ammonium sulfate. It is used in fertilizers. Next is calcium sulfate. It is used in making plaster boards, plaster cast for injured limbs. Next is iron sulfate. It is used in iron tablet. Next is magnesium sulfate. It is used in medicines. Next is barium sulfate. It is used in barium ions, give good X-ray photographs. So these are some uses of the salts. The next thing that we are going to read in the lecture is hard water and soap. Very important topic this is. The question from this topic always come in the paper. So hard water and soap. Hard water is formed in chalk and limestone regions where the rocks consist of calcium carbonate. So when water flows through these areas, hard water is formed. The acid is carbonic acid, which is formed when carbon dioxide dissolves in water. So this is the reaction. Carbon dioxide will be dissolved in water to form carbonic acid. The soluble salt formed is calcium hydrogen carbonate. So when calcium carbonate is dissolved in carbonic acid, so calcium hydrogen carbonate will be formed. The calcium ion in the water makes it hard. So this is the calcium ion which is responsible for making the water hard. Hard water formed in this way is temporarily hard. So the process can be reversed. Calcium hydrogen carbonate is decomposed by heat. On boiling, it splits up into calcium carbonate, carbon dioxide and water. So water will get soft again. The calcium carbonate appears as fur in kettles and hot water pipes. So you have ever seen kettles? So they're formed fur around the edges. That is actually calcium carbonate. Washing in hard water. Soap is the sodium salt of a long chain organic acid. It is soluble salt. The other soluble salt in the calcium hydrogen carbonate in the hard water. On mixing, the two soluble salts, a precipitate of an insoluble calcium salt of the soap acid forms. So calcium stearate plus calcium hydrogen carbonate forms calcium stearate plus sodium hydrogen carbonate. Water softening. Bath salts are used to soften water and save soap. So bath salts are used for making the water soft. They are colored and scented forms of the sodium cisco carbonate, sodium carbonate, sodium hydrogen carbonate. They work by precipitating calcium ions as calcium. So this is the process to make the water, hard water, into soft water. So this was the lecture, students, a lengthy one, an important one. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.